In a stunning leap forward in underwater technology, Chinese scientists have achieved something once thought nearly impossible. They've successfully transmitted acoustic signals without a single error over a staggering distance of 375 miles. That's roughly the stretch between Taipei and the US military base in Okinawa. This incredible breakthrough, developed by Professor He Changbing and his team at Northwestern Polytechnical University in China, isn't just another academic milestone. It's a bold stride into the future of submarine communication with profound implications for both military and civilian realms. To understand the magnitude of this accomplishment, we have to dive into the physics of underwater communication. Unlike radio or optical waves, which quickly vanish in seawater, sound waves are the only viable means to send messages beneath the ocean's surface. But even sound has its limits. Seawater is chaotic, filled with echoes from the seafloor, Doppler shifts from moving sources, and constant ambient noise. Maintaining a clean, error free signal over hundreds of miles has always been an enormous technical challenge. What makes this tech extraordinary is that it doesn't require any prior knowledge of the seabed. It can adapt in real time, identifying signal clusters in noisy environments using artificial intelligence and advanced mathematics, and that's just the beginning. The team developed a transformative algorithm that turns messy, unstable communication channels into what they call acoustic snapshots. Imagine layering multiple blurry photographs until a sharp image emerges. That's how their system corrects errors, refining the signal over time with pinpoint accuracy. The system was tested in deep sea locations, averaging over 3 miles in depth. Using an 8-element hydrophone array and coded QPSK signals, it achieved a data rate of 37.5 bits per second, modest in speed but unmatched in clarity and range. Even more impressive, it used a 176 decibel sound source in the extremely low frequency range, ideal for reaching far beneath the waves with minimal loss. Now, this isn't the first time long range underwater communication has been attempted. Back in 2010, the US Navy managed a similar feat over 342 miles, though not without significant errors. And going further back, the Navy's ELF project used massive antennas to ping submarines with tiny bursts of data, but those systems were limited, slow, and infrastructure heavy. What China has developed is mobile, adaptive, and perhaps most importantly, scalable. Strategically, this gives China a powerful edge in undersea warfare. Submarines can now receive commands or send back information without surfacing or exposing their location. Dormant underwater drones can be awakened at a moment's notice, and deep sea surveillance networks, sometimes called the underwater Great Wall, can operate with tighter integration and autonomy. But the implications go beyond the battlefield. In marine science, this tech could revolutionize how we collect real time data from the ocean floor. It could enhance early warning systems for tsunamis or earthquakes. And in the commercial sector, think offshore oil rigs, undersea pipelines, and autonomous underwater vehicles communicating seamlessly across vast distances. Still, challenges remain. The system demands massive computing power. Processing a single message requires teraflop scale performance. It's currently impractical for smaller drones or real time battlefield use, and environmental volatility, like sudden storms or rapid underwater movements, can still disrupt the signal. If you found this deep dive into cutting edge tech as fascinating as we did, don't forget to hit that like button. Subscribe to our channel for more insightful stories at the intersection of science, defense, and innovation. And let us know in the comments, do you think underwater communication will redefine the future of naval warfare?